Wednesday, January 29th. This is CS 746, Perspectives in Data Science. Today's lecture is on data collection. The purpose of data collection, of course, is to get something to work with. You can't just manufacture data out of thin air, obviously, right? So, and of course, in our course outline, we're on topic number 3. So we're just going in order so far. So we're going to do a comprehensive overview of data collection techniques here today. Excuse me. Data collection is a foundation of any data science project. In fact, collecting and cleaning your data is what a lot of data scientists spend the majority of their time on, right? So there are different ways to get data based on the source that you use, that you get the data from, and the approach that you take to collect it. So primary data is the first step. Primary data is collected directly from the source. So common methods, you go out and you create a survey online, SurveyMonkey, something like that. Or you do interviews. You have students come into your office, or if you're a physician, you're collecting information about a patient. That is a primary data collection of information from the patient about their health. Observations. So you can go out there and monitor or record behavior. So we have traffic signals out there that have cameras on every single traffic light in the city out there, right? So it's watching traffic go by, and so they can count how heavy the traffic is. More importantly, if a couple of ornery students from Oklahoma State University decide to steal a statue off the Wichita State University campus and drive off with it in the back of their truck and then throw it into a pond because they realized it was a dumb idea, the Wichita State University police, and the guy told us this story, can actually contact the Wichita City police, say we need to find out where this car went, and they can track the car and see where it stopped. And they were able to find out who these students were, identify them, go down and say, okay, you got to pay for that statue that you stole, and also put it back. So observations, experiments, controlled studies to collect data on specific variables. So again, scientific experiment, a classic double-blind experiment. You design something like this, an effect you want to test. You have a control group, you have an experimental group, you see what the differences are. In data science, we have a approach called A/B testing. So we can collect data using an A/B test where, Google will want to try out a new user interface. If we move this button over this way a little further, do we get better responses, right? And so they'll send out to half the people out there. They'll send the old version, and the other half the people will send the new version. They'll see, which people, use that button more, right? Buy the product, whatever it is. Secondary data collection is obtained from existing sources. These can be public data sets. So government reports, there's a web page out there called data.gov, or at least there used to be until, I don't know, if they're still working on that right now. Research publications, so on and so forth. They can be web scraping. Web scraping is going out to websites that may or may not be cleanly organized, may or may not have APIs on them, using scripts to scrape the information on that web page. It's basically, like, pictures like scraping snow off the windshield or something, right? API, application program interface. This is the way that large platforms like, oops, not Twitter, I'm sorry, X now, Twitster, Google, OpenWeather, Facebook, all have application program interfaces where you can write a Python program that'll act like a web browser kind of, and it'll be sending requests to the web page, but they are in a structured format, so you can literally go out there and do your shopping using a Python program on Amazon, right? Finally, databases. If you've got the information has been collected, stored in a database, you can use either a SQL database, relational, or a NoSQL system. How to find APIs. API is not just open. You can't just start sending REST API commands to Google. You have to authenticate yourself. You have to get a license or a public-private key from them to verify your identity so that you aren't, can prove you're not a spy. So to find the APIs, if you have a specific site, you want to see if they have an API, there should be a developer section on that website, right? So if you want to, if you're looking at a WordPress file, older application, but people are still publishing things in WordPress. You know, it'll say this is a WordPress down there in the corner. You can then go to wordpress.com and look, and there's a developer section. It'll tell you how to access the API. Or you can go into Python, say search, Google search Python and the site name and an API, and it'll probably find you something. Or you can go to GitHub. There's a project at GitHub. Ooh, yes, we're going to go look at that. List of Python API wrappers. And hey, it's all here. Amazon, AWS, Arc, authorized, so on and so forth. So this is a list of all of the API wrappers that someone has already put into Python code. So you just, you know, you don't have to write code yourself. You don't have to deal with the API itself. It's just they standardize it to a Pythonic interface. So whatever API you want to use, you just, you know, writing kind of in a standardized format for Python makes it a lot simpler. And of course, we should probably add to this ChatGPT, but we don't have ChatGPT on there for finding APIs yet. So we can update this slide apparently. Huh? Last resort, of course, is web scraping. And again, HTML is not necessarily formatted cleanly. Web scraping is recognizing that, you know, when you try to go dig through HTML to find stuff, it's a mess sometimes. Real-time data collection, collected dynamically on the fly. Internet of Things. Right, you have a electronic door lock on your front door, which you can unlock with your phone. Well, someone's collecting that data, right? Because they, at the very least, they want to be able to know that their device is working, right? At best, for them, they can sell your information and tell the burglars how often you go into your house and stuff like that. So that would be a great business: sell locks, and then turn around and sell the information about when people are home to the burglars. Never mind. Okay. Logs, monitoring system and application logs. As you boot your computer, it's logging everything that happens. If the hard drive crashes, there's an event that it's logged someplace. It may not be able to save it because the hard drive is crashed, but it'll do that. Social media, gathering user data from platforms in real time. And of course, we all know that on Facebook and Instagram and TikTok, we are the product. And basically that platform exists to sell our information to the advertisers, right? Streaming services, Apache Kafka, Apache Spark, live data streams. So you can go out there, set up some monitor on some device and be creating structured data off of that. We do have to worry about ethical considerations. When you're collecting data, you need to obtain an informed consent. You don't just go out there and take people's data without telling them about it, right? Although we know that happens, sometimes it's unavoidable. But there are laws that govern that, and if you do that intentionally, you can face severe criminal penalties even. You have to ensure the data is private and secure. If you're collecting medical records, right, and you release those, there was actually a story, one car manufacturer was collecting drivers' driving habits. GM OnStar, it's supposed to be a safety thing that'll call when you have a car wreck. It detects if your car suddenly stops, and it says, okay, we're going to call up for assistance, emergency vehicles, whatever. Well, they were actually forwarding people's driving habits to insurance companies, and people were finding their insurance rates were going up, and they didn't know why. And it's because they were speeding, and GM was just not, without telling them. Okay, that's not data privacy. They just had a court case they lost about that. Avoid your bias in your data collection methods. When you start collecting your data, you can come up with something where you get a biased group of people. You design a survey or something like that, especially. The only people that can take your survey are the ones that are willing to respond to it, right? So you have to be aware that sometimes your data collection can get biased. And the relevant regulations, GDPR, the General Data Protection Act, our regulation, it's a European Union law, and it's called the right to be forgotten. Right? And they passed it several years ago, and the state of California passed a similar law where if your data is on a website and you tell that website company, I want you to forget about me, they are required to scrub your data. And, that's harder to do than it sounds like. HIPAA, of course, the Patient Privacy, Health Insurance, Patient Privacy Act. Where you're not allowed to share someone's medical records with anybody unless they give you permission to do so first. Data can be categorized into two types. Broadly, there's structured data and unstructured data. So we got various formats in there: tabular data, text files, images, so on and so forth. We'll look at those now. Structured data, the most obvious example is, a database or a spreadsheet, Excel spreadsheet, comma separated values, right? So you got a table of sales records with maybe columns for the date, item, quantity, and price. Here's an example of structured data. We don't know quite what it is, but we know that, we've got the headers up there. And I like to pretend this is something about they're asking disabled people to go to the next, governor's election of Kansas and vote as many times as they can. But I'm pretty sure that's not what this is. Right? Vote early, vote often. Anyhow, but this is measuring something on here, right? It's a table. Here's a Excel spreadsheet, just a massive table with profit and loss, for all sorts of things. Here's comma separated values. And I love this. It's like A at A.com, B at B.com. Someone was making this for fun. And there's just amusing typos in there everywhere. So anyhow, but that's a CSV file. And you pull up any .csv file in a plain old text editor, and you can actually see what's in there, right? Relational database. This is a star table. Here's their fact table at the center. It's got your keys for the store, the product, what the sales are, the cost, the profit, and so on and so forth. So every time someone sells something, we record the sales, the sell, the cost, and the profit, price, and what it cost us. The store key then tells us where those stores were, and the company can go out there and start saying, they run a special in Los Angeles maybe, and they can find out, if that special is improving profits or hurting profits, right? And yes, these are real movies, but the studio names are just, I don't know what those are. Again, someone was having fun making this stuff up. Unstructured data is not organized in a table. Pretty straightforward. The text document, images, videos, audio files, right? Social media posts. I don't know about you, but I always type my social media posts in JSON format, don't you? No, never, I don't. So an example, you got a folder containing photos or audio recordings or scanned documents. You have the photos directory with, several hundred pictures of my granddaughter out there, right? And that's unstructured data. And Apple tries to go out there and parse it and figure out these are pictures of your dogs. And then all of a sudden there's a picture without a dog in sight. And, it's hard to deal with unstructured data. Here's a text file, just random text file in Notepad. And I don't think this is worth trying to read. We can have image data. And again, someone's gone out there and they took a picture of, for classification. They went up to the grocery store and they took a photo of the fresh produce bin and divided it all up into little squares. And they're trying to train some image recognition software to say, this, I recognize this is a lime down here and this is an orange in the middle and so on and so forth. So try to figure out what's in there. Audio, video data, right? Record, dad playing with a kid or something like that, right? Mac, not GarageBand, whatever, Movie Maker. And there's so many different formats for audio and video files out there. And of course, your folder on your computer can contain all sorts of different data in it. It doesn't have to just be photos. It can be photos and music and everything. There's nothing that stops you from doing that. Semi-structured data has some organizational properties, but is not rigidly structured. It's not a strict table. JSON, XML, MongoDB, and other NoSQL. NoSQL stands for not only SQL or not only relational database. Are examples of that. So here's a JSON data. You can see it starts with curly braces, lists things around. We have keys and values for everything. In this case, we got some company named Lorem, and the full address is 123 Main Street, so on and so forth. Here we see XML, which is a similar format, is more wordy than JSON. Here, XML is based off of HTML. HTML has tags for starting and ending everything. So in this case, we have a first name, end first name, last name, end last name. So it's a much wordier interface than JSON, and it's fallen out of favor, largely for that reason. NoSQL data. This is essentially looking at Python, a nested list of dictionaries. So person has a name and a phone number, and then we have orders from that person. And so instead of having, a relational database, which is in tables, we can go ahead and structure this as a tree, basically, where, at the top level here, and then underneath we have the individual things they've ordered. So, summary. We have structured data that's organized and stored in tables, databases, Excel spreadsheets. We have unstructured data that's raw and unorganized, like images, videos, and text files. We have semi-structured data that's partially organized. And each type of this data has specific use cases in various applications. Another thing that's important to worry about when you collect your data is to remember where it came from and remember what you did to it to make it useful. There's a famous story of in the 1960s, the state of New York ran this huge land use survey of New York, Wilner, however that acronym worked out. And they put on this fancy brand new 1960s era computer, and they put it on like magnetic tape, the latest thing, right? And then they didn't choose the right computer vendor. The computer vendor went out of business. So that database supposedly is still out there. They've downloaded it. You can access it, but they failed to keep a copy of the software they used to analyze it. And the operating system doesn't exist anymore. And the hardware that it was used to run on doesn't exist anymore. So the data file out there is completely useless. Why? Because they didn't manage the metadata correctly. So it's important to remember that, any data about data, right? So we start off with our first lecture was course metadata. It's data about the class, right? That maintains the detailed tracking of the data set's origins, the transformation, the code that you have used to change it into a useful format, the supporting information that says this is where I picked it up and who created it to establish its accuracy or validity. This was just a plain old website. It had no security on it. It was just an HTTP site. When I tried to load it up in my Chrome browser, it says this is an insecure website. Don't trust this. I did anyhow. That's not good data provenance, right? But this is crucial for understanding the life cycle data and ensuring its reliability. And so your key importance of that, several features. First is, two main features, I guess, right? Error identification. If you find an error in your code, you need to be able to figure out where it came from. Is that source unreliable? Is this Andrew Wakefield, who published a study back in the 1990s saying that vaccines cause autism, and was later found out to have faked up most of his data. And now we have, as a result, millions of people believe that vaccines cause autism without any shadow of a doubt, based on a fraudulent study. So bad data collection can cause terrible, ongoing, long-term problems that are very difficult to resolve, right? So, but if we do this with our data, we can then go out and tell whether our data needs to be revisited, find a different data set, something like that. So we can diagnose and resolve issues within the pipeline. It's always changing as it goes through the pipeline. People are out there reformatting things, so on and so forth. So we can figure out why. Critical questions. We need to be able to answer these critical questions. Why was this data produced? Was this an unbiased survey? Was this one of those push surveys where they're trying to get people to give them the right answers they wanted? How was it produced? Right? Was this, someone did this on their smartphone, or someone did this on, a nice secure computer, right? Where was it produced? Right? If we've got two countries at war with each other, we find out that we've got a bunch of data from one of the countries saying that the other country is committing atrocities, is that really the case, or are they doing propaganda? Things like that happen, right? When was it produced? We need to know, is this data out of date, right? And by whom was it produced? Who is the responsible entity for where this started from, right? All this information, if you're doing an actual data science project, trying to make an actual useful product out of it, you need to maintain this information. Otherwise, you could find out at the very end of your process that you got completely bogus data up front, and all of your conclusions are based on flawed input. Garbage in, garbage out, as they say in the computer science, right? So by maintaining comprehensive provenance records, organizations can ensure the data integrity, you can improve your troubleshooting, and you can have more confidence in your data-driven decision-making processes. Data wrangling is kind of the next step. Data collection and data cleaning flow into one another. It's not a waterfall thing or climbing steps where you do the data collection, then you're done, then you do the data cleaning, and then you're done, and then you do the exploratory data analysis, you're done. No, it's a constant feedback loop. Right? So moving from data collection towards data cleaning, we see data wrangling or data munging. If you're a hacker, we like to use funny words. Refers to the process of transforming and organizing raw data into structured and usable format. So the key characteristics of data wrangling, we can get data from different sources. And the idea is that if it's in multiple files, different databases, different formats, we want to be able to bring those together into a single format that we can work with going forward. Right, so you're pulling data in from a sensor, you're pulling data in from interviews, you're plugging it into a giant spreadsheet that you're going to work with going forward. The purpose of data wrangling is to ensure quality, consistency, and usability of the data, thus enabling meaningful insights and accurate decision making. Right, steps and tools. We're combining, joining, rearranging, grouping, transforming the data to make sure that it fits the requirements that we have for our analysis. There may be things we don't care. We can just throw that data away up front for our level of analysis. We're doing a simple analysis kind of thing, right? And there are lots of specialized tools and libraries out there that can make this task easier. And of course, as I would stop and say, ChatGPT will give you great hints, but never trust ChatGPT by itself because it can hallucinate. It can give you the wrong answers. And so you should always trust but verify. Time investment. So you're spending a lot of time on data wrangling as a data scientist. A lot of your time is going to be taken up with having two different data files coming in and finding out a way to reconcile these with each other, right? To the actual analysis, underscores importance, blah, blah, blah. So by following systematic steps and being intentional about your data wrangling, you can take your messy, unstructured data and turn it into a cleaner, higher quality format ready for analysis. And if you find errors later, you'll know what you've done and what you need to do now to make it better. And just make sure that you maintain the history of what you've done to that data. Again, that's the metadata. It's about the transformations you've applied. You don't just start hacking away at the data without writing down what you're doing. All right. Okay. So we're discovering the main steps in data wrangling. First, discover. We understand what the data looks like, what it's telling us, right? So this is exploring, the characteristics of the data. Is it, basic level? Is this JSON? Is it CSV? Is it, whatever, so on and so forth. If it's CSV, does it properly handle quote marks and things like that, or are there are there errors in the CSV because people can make erroneous comma separate value files, right? We're organizing it, structuring it into a coherent format. Lots and lots of irrelevant data when you get unstructured data, stuff you don't care about in there. So we reshape it and arrange it and, determine what the useless information is and record that we're not using that and throw it away. Cleaning it. If you've got somebody inputting the data at a keyboard, there are going to be errors in it, inevitably, right? So you address the issues with your dirty data. So idea is to make sure that you try to minimize your missing values, minimize your inaccuracies, make sure you've got uniform data. Now we're going to enrich the data. The question is, do we have enough information? Is there something we could do to add to this data? You know, is there another data set? Right. So, for instance, we did a project in this class for a couple semesters on trying to find good housing for students who were, you know, out of state, had never been to Wichita, had never been to the United States even before. We're looking for housing in Wichita, Kansas. And, you know, how do you know when an apartment complex is good or not? You know, you look at things like what's the crime rate there? How far is it from campus? If it's far away from campus, how often does the transit run? Because I may have a car when I arrive in the United States, so and so forth, right? So we have to draw data from bus schedules. We have to draw data from police departments, things like that. So we're enriching the data about the apartment complexes more than just, you know, what they say on the web page for that complex, right? Supplementary information to enhance the quality. Validating the data. We want to verify the data is consistent and integral, integrity of the data. So this basically ensures we're meeting the defined quality standards. Finally, the last step, we'll call it publishing, in terms of thinking of this in the simple forward waterfall model where things just going downhill. Publishing is saying our data is cleaned up and ready to go to the next step. And of course, it could come back from the next step. You know, we could go out there and try to do something with it, realize we forgot something, realize we have spurious data in there, right, that you don't need. Right, and we can wrangle it further, but you know, these are the 6 basic steps for wrangling your data. Right. Let's see, data preparation. So we want a data preparation as a process. Processes are best recorded, written down, so that you can reference them later. Right. In fact, it's also best to put your data preparation process, maybe even create a GitHub for it, so that change the process, you can update it, and you can know what it was, you know, in spring of 2002 versus spring of 2025, right? So we want to understand the nature of the data, including structure. We want to clean the data. We want to integrate the data from multiple sources into a single unified coherent data set. And we want to move that data across our systems or networks. We've collected it someplace. You know, maybe we need to have it someplace else, right? When I was working at NetApp Corporation, we sold storage devices to oil companies, and they literally put storage systems in the back of a truck, drove it out in the middle of the country someplace, and then they would set off either explosions underground, or have these huge devices that would just thump the ground with a very heavy weight and create artificial earthquakes and collect huge amounts of data, much more data than they could transmit over the internet. And so they would actually transmit they would move their data by taking the truck to where they were collecting it at, collect the data, and then they would drive that truck back to their data center several hundred miles away and take the hardware out and plug it into their computer, because it was faster to do that than it was to try to send it over the slow internet connections they had available in those days, right? I imagine they would still do that today, because that was a massive amount of data. In order to move your data across your network, you have to do proper serialization and deserialization. Your data in a Python program is in binary format inside the code. It's got minimal protections because it's not doing a lot with it. You're assuming that the computer itself is protecting its memory, has error correction code, things like that. But in order to transmit over a faulty, channel of communication, which can have errors involved in it, you have to add some level of redundancy to that data, and make sure that it is being able to be transmitted efficiently and cleanly. Right, so you convert it into a binary data or a textual format for efficient transmission. And then at the other end, we have to deserialize it, or another word for this you might see is marshalling, where you're taking that data in this nice textual large format and you're pulling it back into your binary format for processing in your software. So when we follow these processes, we make sure we have high quality, integrated, accessible data sets for our downstream applications. In conclusion, it's important to choose the right data collection method. It's critical for the success of your data science project. Because if you don't collect the right data, if you don't collect the data right, if you have garbage, your project's going to fail, right? Or you're going to come up with a project that succeeds but gives people misleading answers, and that's an even worse failure. So consider your project's goals, the available resources, and definitely your ethical guidelines when you're selecting the approach for collecting your data. Finally, a little bit of humor here at the end. We actually had 2 jokes in this slide deck originally, but this is the better one. Because the other one was dated. Anyhow, this is even more data, but it's still kind of amusing here. So this is what? We recognize that? Ozone layer. Yep. What's here in the middle? Antarctica. Yep. And you can do all your geography, New Zealand, Australia, so on and so forth. So back in 1976, they had early spacecraft that were out orbiting the Earth and watching for ozone layers because they knew that ozone protects us from ultraviolet radiation. And it's a very important thing. And when they first discovered this ozone hole, parts per million of ozone was really low. They just assumed the instruments were malfunctioning. So this doesn't make any sense. Something is happening that our instruments aren't working in the cold weather, right? In fact, the data they had algorithms out there that were looking at this, and it just says, it's bad data. They didn't even show it to the researchers up front, right? Eventually, someone discovered this and realized what was going on, that, the chlorofluorocarbons they were putting into air conditioners in the 1970s, when they escaped into the atmosphere, would float up into the high-level atmosphere, and it would bind with the ozone. And this happened a lot more in cold places. And so there was several years of argument over whether that was a problem or not. Heck, it's just Antarctica. And the ozone hole was slowly growing bigger as the freon or chlorofluorocarbons were eating more and more of the ozone. And so eventually they, passed laws banning the fluorine-based coolants that were in use at the time. And so that's why air conditioners all got a little less efficient in the 1980s. But they're still good enough. So that's all I care about. It's good enough to keep me cool in the heat of the summer, right? But it's just, it's things that, when you start seeing something that's really startling, and this would have been a major problem if they had done nothing about it. When you see something that's really startling in data, it's important to recognize that it may not be an error in your data collection. It may be a real issue, right? We're going to talk about outliers later in your data and how to deal with outliers in your data. And sometimes those outliers are real. And sometimes those outliers are someone accidentally typed an extra 0 on the end of someone's age, and that person looks like they're 450 years old instead of 45, right? Okay. It is 11:45. That is our lecture for today. In a moment, I'm going to go ahead and bring up the attendance quiz. I haven't even looked at it yet. But it looks like it's going to be amusing. So you notice out here, still, we are working on, first of all, the integrity contract, which is due on Tuesday night. Less than half the people have finished this yet for the overall class. So if you haven't done the integrity contract, be aware that that is still in your future and you need to get that done before Tuesday. This is a requirement by the College School of Computing, not a class requirement. And they want every student in the School of Computing to sign this integrity contract. And again, save it. As you take other classes, you will probably be asked to sign it again. The small homework 2, beginning the team member selection. Again, If we go to this link, we can see that we've got several people say they're still looking for teammates. If you are one of these people, scroll down, find one of these lines that has a Y on it, ship off a random email, or talk to students in class. You know, you can always say at the end of class, hey, we're still looking for a team, and anybody's still looking for a team can all go meet in this corner over here, and you can discuss whether you think you'll make a good team or not, right? Share what your interests are, things like that. And someone's out there working on it right now. Yeah. Again, focus on your team and people working individually. Some people want other members. They've got 3 people on this team. You don't have to have a team name yet. We do want you to work on team logo. So we've created small homework too. And this is just for fun, but it also counts as a nice free point for your score. Go ahead and upload your team logo. Your logo can be should be submitted by everyone. Once you've got a team, just go ahead and upload it. It can be in any format: PDF, doc, image, JPEG, whatever. I was making a joke that they should do a .txt file as the logo and just upload a little smiley face emoji. That's my logo, right? You're going to change your logo going forward if you want to, but you're having fun with this logo. Right? It's just be a silly, kind of thing. So you don't have to. Also, this is graded. I see we've made a small error here. 1. This is a single point small homework, not 100 points. Anyhow, and that is also due Friday at midnight. So upload something. Again, upload any format, whatever you feel like. If you want to make a fun picture, cool. Probably don't make a massive 2.5-hour movie for your logo. That would be probably a bad choice. So make it something that fits in Blackboard. But, now someone's going to upload Lord of the Rings trilogy. This is my logo. Okay. Lecture links. We are here. We've enabled our Python debugger. We've done our data. We haven't enabled our Python debugger. We tried to, but we have to mess with it later. So 11:49, we can go ahead and do our attendance thing here. We can go ahead and stop recording.